All right, here we are substituting in a formula and rearranging formula. We're going to follow 4 basic steps when we're doing this. Okay, step 1 is write down your formula. 2, state the values of your known variables using the variables you have. Step 3, substitute the known values into the formula to form a 1-variable equation. With an equation with 1 variable, we can solve. Later in this unit, we will be solving with 2 variables using 2 separate equations. Step 4, solve the equation for the unknown variable. So here we are solving for v. Notice where v is in the equation. We are going to substitute in our values for u, g, and t. All right, so for part A here, we're going to find that v is equal to u, 15, plus my g, 9.8, times my t, which is 10. Now I can evaluate this. So I have 15, 9.8 times 10 is 98, and 15 plus 98 is going to be 113. Okay. So in B, might have a couple more steps because we are actually solving for t. Okay. But now we have a v, a u, and a g. Okay. So my v is 45 is equal to my u, which is 20, plus my g, which is 9.8, and my t is unknown. So I'm going to isolate my t. So I always kind of like to circle and know that, okay, my goal is to eventually down here get what t is equal to. So I'm trying to isolate t. So first thing I'm going to do is I'm going to undo the adding 20. So I'm going to subtract 20 to both sides. And I get 25 is equal to 9.8 times t. Since t is being multiplied by 9.8, my undoing of multiplication, or my inverse, is dividing by 9.8. So I divide both sides by 9.8. And using a calculator, 25 divided by 9.8, I'm going to see that we get t is approximately equal to 2.55. Okay. So, looking at our next one, we're looking at the volume of a cylinder, where it's dependent upon our radius and our height of our cylinder, where a radius is from our center out and the height is from our base up. Okay, so the volume the volume of a cylinder with a base 2 and a height of 5. So we're going to find the volume. Okay, so we're going to substitute in, and we're going to have pi. My radius is 2 squared times my height. Okay, I'm going to simplify before I put in my calculator. I'm going to have pi. 2 squared is 4, then times 5. So this is going to be equal to 20 pi. And when I do 20 pi in my calculator, I'm going to get approximately, because I'm going around, 62.8. And anytime I'm dealing with geometry or story problems, I should think about my units. So we are thinking about volume, and we're dealing with centimeters, so we're centimeters cubed. Okay, that was A. Part B. The base of the radius of the cylinder has a volume of 10 and a height of 3. So we need to find our radius. So our radius is our unknown. Our volume is given by 10. So V is equal to 10. Okay. And then I have pi. My radius is unknown. Okay. And then my height is 3. Okay. So first I'm going to divide. So this is all multiplication here. So if I divide both sides by pi and by 3, divide by pi and 3, okay, I'm going to see that the pi's and 3 are going to cancel out on my right side. I'm going to be left with r squared, and 10 divided by pi times 3 is going to be about 1.06. Since this is squared, I have to undo a square by doing a square root. So I square root both sides. And what I'm going to find is that my radius is going to be equal to 1.03. And again, we're dealing with meters. Units are important. And we're there. Okay. Let's look at another example here. So a formula can be rearranged to make a different variable. The subject, remember, we are doing inverse operations. So I always kind of do a talk aloud to myself of asking what is happening here and what is the inverse operation. We know those inverse operations for our addition and subtraction, and then multiplication and division. Okay, and as we have things that are squared, we have square roots. Okay, so if I want to make x the subject of this, that means I want to get x by itself. My goal is x equals something. So I have to undo the things on the right side here. So looking at this, I'm first going to deal with my k value. So I'm going to subtract k from both sides. I get m minus k is equal to 3x. Well, that's a multiplication here, so divide by 3, divide by 3. So I'm going to see that x is equal to m minus k divided by 3. This can be useful if we're trying to solve for x and we have m's and k's. We don't want to do the algebra over and over again. Okay, so if we want to make g the subject here, okay, so again, I like to identify where my g is, and my goal is going to be g equals something. Okay, so first I'm going to do, I don't like division, so I'm going to multiply both sides by g. Okay, so then I have g at times n equals a. Okay, and then I'm going to, remember I'm trying to get g by itself, so I have a multiply by n, so I'm going to divide by n on both sides. And I get g is equal to a over n. Okay. And we have made g the subject. Okay. Next example. Okay. So if we're trying to make c the subject of the formula, again, I'm going to do the same strategy of getting rid of my division. And here I'm going to cross multiply. Okay. So since I have an equal sign, I have b and c. I'm going to multiply those out. I get b times c is going to be equal to my other cross, which is 2 times a. And now I have a simple multiplication problem. So since my goal is to make c my subject, I identify where my c is, and I'm going to undo the multiplying by b on here to divide both sides by b. So I reach my goal of c, because that goes to 1, and 1 times c is c, and I get c is equal to 2a over b, and since c is my subject. Last example here. Area of a circle of a radius r is given by pi r squared. Rearrange this formula to make r the subject. So again, I have a is equal to pi times r squared. So since my goal is to have r by itself as the subject, first going to divide both sides by pi. And I have a over pi equals r squared, and my inverse operation of squaring is taking the square root of both sides. So I do that to both sides. That's going to cancel out my square. So I'm going to have r equals the square root of a over pi. Okay. Part B. Okay. Hence, find the radius of a circle with an area. So this is why it's useful to sometimes make r our subject or another variable our subject, because we are given these values. These are a values. They're areas, and we know that because that's what it said, and by our units. So we want to know what size circle gives a area of that 10 centimeters squared. We can use our formula that we've already solved for in part A without doing any rearranging. Okay, so if we know, we do the square root of 10 being my area divided by pi. Okay, using my calculator, I have square root of 10 divided by pi, and I'm going to see that that's going to give rise approximately, it's irrational, but we get 1.78, and my units again would be centimeters, would be the radius that gives a 10 centimeters squared thing. Okay, my next part I want to do is same idea, but we are going to do it for 20. So square root of 20 divided by pi. Okay, so square root of 20 divided by pi is about 2.52 centimeters. That concludes our notes for today. Please highlight any questions you may have and bring them to class tomorrow.